welcome to the last section of Module 7. In this video, we are going to be using what we learned about ratios and proportions, and we are going to apply them to real-life scenarios. So, in the last section, we learned about what proportions are and how to solve them given a missing value. Now in this section, we're going to apply that knowledge of proportions, like I said, to solve real-life scenarios. However, prior to doing that, let's take a look at how we would set up a general proportion. So there's this general proportion, the setup of a general proportion, where we take an initial value of a given ratio and the denominator of a fraction, and then we take a new value of this given ratio, and then we can set this fraction of this ratio equal to another equivalent ratio with this ratio's initial value and new value. So that's a little bit confusing when I talk about it, but it'll begin to make a lot more sense once we go through some examples. So with that being said, in the following examples, let's solve the word problems by setting up a proportion. And then once we get that proportion set up, then we're going to solve for the unknown value or what we're solving for. And if needed, we are going to round to the nearest hundredths place. And just so we all are on the same terms, or the same understanding, hundredths place is second decimal place. Okay. So with that being said, let's look at example 1. So it says Jasmine bought 32 kiwis, or 32 kiwi fruit for $16. Given that information, how many kiwis can Lisa buy if she has $4? So let's set up a proportion. So we know that we can get 32 kiwis, or we know we can get 32 kiwi for $16. So this here is a proportion or a ratio. We can set that equal to, well, we know that she has $4, so we're going to put that in the numerator of this new ratio or equivalent fraction. And then we're going to say, well, based off this information, we can put x in the denominator for an unknown amount of kiwi. And then here, we're going to solve this proportion by solving for x like we did in the previous scenario. So we're going to cross multiply. So we're going to get x times 16, or 16x equals 32 times 4. And then we're going to simplify this a little bit more. So we're going to get 16x equals, and 32 times 4 is 128. And then we're going to divide both sides by 16 to get x on its own. You're going to get x equals 8 kiwi. And that's your final answer. Lisa can buy 8 kiwis with $4, given this original ratio. Now example 2, it says the currency in Argentina is the peso. The exchange rate is approximately 3 American dollars or US dollars for every 1 peso. At this rate, how many pesos would you get if you exchange $121.10 of US dollars? So we're going to set up the ratio that we know. So we know for every 1 peso, you get 3 US dollars. And now we want to know if we exchange $121.10, we want to know how many pesos we'll get. What is our X amount of pesos? So let's cross multiply. So we're going to get 1 times, well, let me write X on the left-hand side of the equation. So we're going to get 3X, because we get X times 3. So 3X equals 1 times 121.10. In other words, we just get 3X equals 121.10. And then to solve for X, we're going to divide by 3 on both sides. So you're going to get X equals $40, approximately. I shouldn't say $40. You're going to get approximately 40.37 pesos. There you go. Now, looking at example 3, I encourage you to pause the video and try it on your own. And now let's work through it together. So it says, the ratio of boys to girls is 3:2. If there are 12 boys, how many girls are there? So we want to know, the question is just how many girls are there, but given that information that the ratio of boys to girls is 3:2 and that there are 12 boys. So I'm going to write this first proportion as we know that there's a total of 12 boys. We know that there's a total of 12 boys. And we want to know how many girls there are. So we're going to write X girls, because that's what we're going to want to solve for. And then we're going to set this equal to this ratio here. So we know that there are 3 boys for every 2 girls. So because of that, I'm going to write 3 down in the denominator with boys. And then I'm going to write this 2 matching up in the numerator with the girls. And then from there, we can solve this proportion and cross multiply. So we get 3 times X, or 3X equals 12 times 2. So we get 3X equals 12 times 2 is 24. And then to solve for X, we're going to divide by 3 on both sides. And you're going to get X equals 8. Or in other words, X equals 8 girls. And that's your final answer. Looking at example 4, I encourage you to pause the video and try this one on your own. Now let's work through it. So, if Mason ran 5.5 miles in 2,310 seconds, what is this average rate per mile in seconds? So we can set up a ratio. We know that for every 5.5 miles, Mason runs for a total time of 2,310 seconds. We want to find out his average rate per mile. So we know that his average rate per mile means for every 1 mile. So we can put 1 mile in the denominator here and then solve for X amount of seconds. So to do this, to solve this ratio now, we're going to cross multiply. So you're going to get 5.5 times X equals 1 times 2,310. So you get 5.5x equals 2,310. You're going to divide by 5.5 on both sides to solve for x. And then you're going to get x is approximately actually not approximately, you get a full number actually. a whole number, and that is 420 seconds per mile. Okay. Again, example 5. Actually, I encourage you to pause the video and go through the last 4 examples on your own and give them all a try. And assuming you have worked through all of them, let's go through the remaining questions or examples of this unit. So for question 5, it says, if a jogger runs 2 miles and burns 185 calories, how many calories would he burn jogging 5 miles? So we're going to set this ratio up so we know for every 2 miles, this jogger burns 185 calories. And then we're going to set this up and put 5 miles in the denominator because we want to know how many calories that this runner will burn, given that this runner runs 5 miles. So let's cross multiply. So we're going to get 2 times x equals 5 times 185. So we're going to get 2x equals 5 times 185 is 195. My apologies. I miscalculated that. Let me get my calculator out here real quick. So 5 times 185 is 925. And then to solve for x, we're going to divide both sides by 2. So you're going to get x is approximately 925 divided by 2 is 462.5 calories. Okay, for our next example, it says a meteorologist reports that the ratio of snowfall in January to the total snowfall during the average winter is 2 to 5. If 34 inches have fallen in January of the current year, find the predicted total snowfall for the entire winter. So we know that the ratio is 2 to 5. So we can say there's a total. We know that the total, or because this ratio 2, or this number 2, is resembling the amount of snowfall in January on its own, and that 5 is the total amount of snowfall in the entire winter, we're going to set this ratio as the initial value of 5, or the total value of 5, and then set 2 above it for this new value, or this partial value, you can think of it as well. And then from there, we're going to set it equal to, well, we know 34 inches have fallen specifically in January. So we're going to put that here, that's 34 inches in January. We want to find the total inches in the entire winter. And then now, to solve for x, we're going to cross multiply, so you get 5 times 34 equals 2 times x. And then you're going to do 5 times 34, which is 170, equals 2x. And then to solve for x, you're going to divide 2 on both sides, and you get x equals 170 divided by 2 is 85 inches. So you get 85 inches of snow in total. Okay. Looking at number 7, Mr. Johnson was paid $190 for a job that required 40 hours of work. At this rate, how much should he be paid for 60 hours of work? So we know for 40 hours, Mr. Johnson was paid $190. And using that an equivalent ratio, we can say, well, what about if he worked 60 hours? How much would he get paid? So let's cross multiply. 60 times 190 equals 40x. And to solve for x, 60 times 190 is 11,400 equals 40x. And then from here, we're going to divide both sides by 40 to solve for x. And you're going to get x equals $285. So if Mr. Johnson worked 60 hours with this, given this equivalent rate, or this rate, he would get $285. Okay. Last but not least, a pump can fill a 750-gallon tank in 35 minutes. How long will it take to fill a 1,000-gallon tank with the same pump? So we can set up a example of what we're given. So we're given 750 gallons for every 35 minutes. Or in other words, in 35 minutes, we have filled up a 750-gallon tank. And at the same rate, we want to know how many minutes will it take to fill up a 1,000-gallon tank. Let me read this. Oh, wait, minutes. There you go. There you go, that looks better. And then to solve for x, cross multiply. So 750, x equals 35 times 1,000. So you get 750, x equals 35,000 divided by 750 on both sides to solve for x. And you get x equals approximately 46.66 repeating. Or in other words, because we want the original direction set to round to the nearest hundredth, you'd say 0.67 minutes. And that's your answer.